Hello, everyone. So, today we shall be diving into an interesting topic titled airflow. We shall be looking at the dynamic of airflow. In this topic, we shall explore the fundamental principles that govern the motion of air, from gentle breeze to powerful aerodynamic forces. I'm sure you'll be interested in this. So, let's dive into this. Okay, so firstly, we are going to look at what airflow is. Airflow simply describes the air molecules in motion. Unlike liquid, air doesn't need a channel to flow. Wind is formed when air molecules are set in motion by various processes. So the word we refer to as wind is just simply air in motion. And there are various processes that set air in motion. Number one is by blowing air. You can blow air with your mouth, you can blow air using your hand fan, and you can use an electric fan as well to blow air, and use your mouth to blow air, and air will be in motion. You can also use pump in blowing air or even bellows. So these are four major processes that can be used to set air in motion. So when air is set in motion, then we can now talk about we having wind. So just like we have two ways at which liquid move, you know, liquid can move in laminar, liquid can flow in laminar form or in turbulent form. When liquid are moving in laminar form, it means that they are moving gently in parallel paths like a smooth river, as you could see in this diagram. So there are liquid that move in this laminar form. Okay, we say there is a laminar flow. Same also applies to air. Air too can move in a laminar way. Second way that liquid can move is called the turbulent flow movement. In this case, the liquid forcefully move or forcefully flow, okay, and they do not move in a straight line, unlike laminar flow. So it's like water in a drainage. You see a sample here, water in a drainage during every downpour. You see the water moving in different direction because it is turbulent in nature. The same applies to air. Air can be turbulent in their movement or in their flow, and they can also be laminar in their flow. All right, so that leads us to the energy in moving air. You see, moving air possesses energy, and this energy can be harnessed to do various things. We use the energy in air to turn windmills. Windmills are actually instruments that use wind, that make use of wind to convert the energy into mechanical energy. The sample of windmill, just like a fan. But what happens in windmill is, as the air is blowing the the fan of the windmill, it keeps turning, and as it's turning, it is converting that energy into electrical energy. So that's one way in which the energy in air is being harnessed. Windmill make use of it to generate electricity. Another area or phenomenon we can observe that there is energy in air is in waving flag. Okay, this is a Nigerian flag. The movement of this flag is as a result of the energy of the air that is blowing it. If there was no energy in the air, this flag would not be moving from one direction to the other or be waving from one direction to the other. This is another phenomenon that shows that there is great energy in moving air or in airflow. Another area we can observe the effect of moving air is in hurricanes. Hurricanes are very, very strong storm that come with heavy downpour, as well you could see. This is a sign that there is energy in moving air. This is a sample of hurricane coming with a very strong storm, destructive, and also come with heavy rain. So these three samples shows that there is energy. in moving air. So, with this energy, a man called Bernoulli propounded a principle that was named after him, and that's Bernoulli's principle. What is the principle of Bernoulli? Bernoulli's principle states that at high speed, pressure is low or pressure is reduced, and at low speed of air, pressure is high. In other words, faster air means lower pressure. Faster air means lower pressure. You could try this with what this man is doing. You could see this man blowing air between two sheets of paper. Now, as he does that, you find out that the paper moves together. But on the other hand, the papers are supposed to move away from each other because air is being blown between them. The reason why these papers are coming together is because the air being blown by the man is moving with high speed, leading to low pressure between the papers. And when there is low pressure, the paper tend to come together. That's an example to prove Bernoulli's principle. The faster air leads to low pressure in that area. So the speed of the air within the space has reduced the pressure within the space, and it has made these two papers to come together. And this principle is also applicable in the lifting of aircraft. The airplane we see today moving in the air also make use of the Bernoulli's principle. And we get to know that. Okay, so that is what we call the aerodynamics, the science of flight. You know, you keep wondering what makes aeroplane to remain in the air and keep flying in the air. Aerodynamics is the science that studies the forces acting on objects moving through air. Okay, so that's what aerodynamics does. It's a science that studies the forces that act on objects that are moving in the air. And one of the common objects that move in the air is the airplane. Now, this is a video that shows how an airplane moves in the air. Now, there is a major part in the airplane that allows the lifting of plane, and that's the wing of the plane. The wing of the plane is designed in a way, let us pause this so that we could see it together. So look at the wing of the wing of the plane. It is designed in a way that the top is streamlined. Okay, the top here, the upper part of the wing is streamlined so that air can move faster. And according to Bernoulli's principle, as air is moving faster, all right, the pressure there will be low. And that is why the wing might not be able to move faster at the top part of it, but at the lower part, the air there is slow because of the way the wing is designed. Okay, so the moving of air is slow here, and then you have high pressure. So due to high pressure, the pressure that exerts on this wing from below lift up the wing to higher position. Okay, so that's what happened during the lifting of aircraft. The wing, the lower part of the wing of the plane is designed in a way that air moves slowly within it, and then that leads to high pressure within that area. And that high pressure is what pushes the wing of the plane upward, which by implication moves the aircraft too. And that's what this video is portraying. Okay, let's have a glimpse of it again. We see now that the slower moving air now is what gives high pressure at the bottom. So that's how it works. The plane now can lift high and high and high and high because there is low moving air below it and then high pressure below it. So this is how airplane move and fly. All right. So let's talk about some forces that act on aircraft. There are four major forces that act on aircraft, and the first one is called the lift. The lift act upward, okay, as you can see here, it only act upward on the plane. It's always opposing the weight. The weight act downward. Okay, you can see here the arrow pointing down. So the weight act downward due to gravity, while the lift act upward, okay, upward opposing the weight. The third force is called the drag. The drag is one that opposes the motion of the plane. Okay, you can see here that is towards my right side. And then the last force is called the thrust. This force propels the plane to move forward. It could be any other object aside from plane. It could be helicopter, any object that flies in the air. There are four forces that act on them: the lift force that act upward, the weight force that act downward, the thrust force that propel the object to move forward, and the drag force that pull the object or that move against the thrust force. Okay, so we use W to represent the weight, L to represent the lift, D to represent the drag force, and D to represent the thrust force. So Bernoulli's principle can also be applied in air balloon. It's applicable in the flying of kite and also in jet engines. So these are the three areas of application that we would like to mention for Bernoulli's principle. Alright, I hope you have learned something today about airflow, its application in science, and also the different way that air moves. So I would like to draw the curtain here today. So thank you for watching and have a wonderful day. Bye for now.